In this video, I'm going to introduce you to some properties of logarithms, and we're going to actually focus on expanding logarithms because I know a few of you in class have had a little bit of trouble with it, so I want to go over the details of how we do this. We're going to be using the power property for some of these because we're going to have exponential powers. So notice right here we have a power of n to m, and with the power property it just says that if you have a log with a base and then you have your value right to the power of something, you simply take that power and put it in front of the log. So that's a way to transform it so that you can go ahead and expand it. So that's something that's going to be occurring. Next we have our product property, which product means multiply. So in other words, notice we have m being multiplied to the letter n, and anytime we have a product property we're going to simply add those two values. So notice we have log b m, right, and then we have plus log of base b to n. And so all we did was take these two values, right, these two variables that are being multiplied, and we separate them as two different logs being added together. So I like to think about this like your exponent rules, right? In exponent rules, we have the same base, we simply add the powers. So here what we have is when we have the same base, right, it's both base b, we simply add these two variables that are being multiplied together as two separate logs being added. Next we have the quotient property, and just like in exponents, when you have the quotient property and you're dividing something with the same base, you subtract the powers. Well, it's kind of the same idea here. Notice we both have log b, so they all have a base of b, and we have m being divided by the letter n, so therefore we create two separate logs, one log of m, right, and then we have another log of n, and we are simply subtracting them. So we'll be using these three different properties as we go through these problems, and I'll be referring to them at times. So let's start with example number 1. So example number 1 right here, notice we have a natural log, so ln of 5x to the 6th power. So notice we do have multiplication going on and we do have a power. So the reason I mention this is because we're going to have multiple rules that we're going to use in order to solve this problem. We are going to have to use our product rule because multiplication is occurring. But since we have a power, we're also going to use our power property in order to remove the power from that variable and place it in the front. So if I were to break this down, the first thing that I'm going to do is I'm going to deal with the product property. I know that 5x means 5 is being multiplied to x. So if I were to rewrite this, I would write it as ln 5 plus ln x to the 6th power. So notice all I did is this is the 5, I'm going to draw an arrow, and here's my other log, ln x. So I just created two separate logs just like here, right, log b of m and log b of n, and we're adding them together. But we're not done because we have this power up here, so we have to address this power. So I'm simply going to take that power and use my power property, where I'm going to take that power and place it in front of the log. So it is going to go up here in front. So when I rewrite this, it's going to be ln 5 plus 6 ln x, and then that's my final answer. This has been expanded. I use the product property and the power property. So now in this next example, notice we have another logarithm, and we have a lot going on here, right? We have a 7 that's being multiplied to an x squared, and it's being multiplied to a y to the 3rd power. So let's go ahead and we're going to break this down, and we're going to use some of our properties to do so. So the first thing we want to do is I notice that this is all being multiplied out. So we want to go ahead and we want to use our product property, which means we're going to set it up as multiple logs that are being added together. But unlike the previous one that just had two terms, this one, because we have three different things, we have this 7, we have this x, and we have this y, we're going to go ahead and break it up into 3. Now before I do so, I'm just going to kind of show you what I mean by breaking it up. For instance, I have log base of 3, 7, and I'm just going to put a dot here. This is being multiplied to x squared, which is then being multiplied to y to the 3rd power. And I'm just spreading it out. I'm kind of like dissecting it. I'm spreading it out to make it a little bit easier for you to understand what I'm about to do. So now what I'm going to do is use this product property, and I'm going to rewrite this. Now instead of log b, we know what our base is. Our base is a 3. So instead of log b, I'm going to put log 3. So I simply will have log with a base of 3, 7, and then I'm going to add that plus log with a base of 3, x squared, plus log with a base of 3, y to the third power. So hopefully by me kind of separating these with the multiplication symbol instead of leaving them all next beside each other, right, without anything separating them, hopefully that made it a little bit easier to see how I converted this to that. This one became this log, and this one became that log. Now we're not done yet because we have these powers. And so now what we're going to have to do is we're going to have to go ahead and use our power property. And we're going to have to take that power that's on the variable and put it before the log to finish this up. So I'm going to go ahead and rewrite this. This is going to be log base 3 of 7 plus, and in this case I'm going to take that power of 2 and run it in front. So it's going to be 2 log base 3 of x plus, and to the y cubed, I'm going to take that value of 3 and run it in front. 3 log base 3 of y. And then this is my final answer. It is now expanded. Now in these last examples, we're going to use the only rule that we have left, which is the quotient rule. So notice if I go ahead and go back up, the quotient rule, our quotient property, says that anytime we have a log, right, with the same base and we have division occurring between two variables, what we can do is just simply subtract them, right? And it's just like the quotient rule on exponents. So we're going to go ahead, we're going to use this rule on one of the examples, and then on the next one we're going to use the quotient and the product rule. So let's go ahead and take a look. So we're going to do the simplest one first, which is this one on the right. So we simply have x being divided by 2y, right? And so I'm going to go ahead and I'm going to write this as ln of x. I'm going to do my numerator first, minus ln of 2y. Now you might be tempted on a problem like this to stop at this point, but we can't actually stop just yet because this one on the right side can be broken down further. In other words, this one that you see down here, right, our denominator, that is actually 2 being multiplied to y. So notice here we have this 2y that's underneath, right? And so therefore x is not only being divided by 2, but it's also being divided by y. And since it's being divided by the 2 and the y, we need to break this up into two different logs that are being subtracted from the numerator. So I'm going to go ahead and write ln x minus, because that's coming from here, and then we're going to break this apart into two different pieces, our 2 and our y. So I'm going to put minus ln 2 minus ln y. Now we're going to do our last one. And in this one, notice that we have in our numerator 8x cubed being divided by y squared. So in this case, we're actually going to use the product rule for the top portion for the numerator, and then we will use the quotient rule to go ahead and subtract out what's in the denominator. So let me show you what I mean. For instance, on this one, I'm going to go ahead and have ln 8 plus ln x to the third power, so x to the third power. So notice what I did is I separated, right? We have the 8 right here, we have the x cubed right here, and then we have to deal with this denominator using our quotient rule. So then I'm going to have minus ln y to the second power. So at this point we're almost done. But we can't leave these powers up here. I can't have this power of 3 and this power of 2, right? If we're expanding it, we need to bring that power over to the front. So in our final answer, we'll have ln 8 plus And this power of 3 will come right in front. 3 ln x minus, and then this 2 will come in front. And then I'm going to write 2 natural log of y. And then this is our final answer. It can't be broken down any further.